Thanks for watching my video. Today let's discuss some application of our Rolle'S theorem. Okay, we have proved the theorem already. Now let's discuss some example. Okay, now here our question that so that between any two roots of e to the x cos x is equal to 1 there exists at least one root of e to the x sin x minus 1 equal to 0. That means in this e to the x cos x equal to 1, these have two roots. Okay, these have two roots, and out of two roots one of the root is this one. It means, okay, now we are going to use our Rolle'S theorem to prove this one. So first of all, let alpha and beta be the two roots. Okay, since it says two roots, okay, now let's say alpha and beta be the two roots. So from the equation cos x is equal to 1. Now if you put the two roots, okay, then you get what? E to the alpha cos alpha equal to 1 and e to the beta cos beta is equal to 1. Okay, we will get this. Now let's define a function. Define a function. Define a function f as follows. Now let's define a function f of x, which is e to the negative x minus cos x, such that x is belongs to or close close interval alpha and beta. Okay, let's say this too. Oh, I'm sorry, this will be close. Now obviously from Rolle'S theorem say that this function f of x is continuous in closed interval alpha and beta and derivable in open interval alpha and beta. Okay, now if you take the differentiation, this one negative e to the negative x minus become plus, okay, sin x, where x belongs to open interval alpha and beta. This is Rolle'S theorem. Okay, now let's put f of what alpha is equal to what f of alpha in this equation. Okay, now e to the minus alpha minus cos alpha. Now if you simplify this, you get 1 minus e to the alpha cos alpha over e to the alpha, which is obviously 0 because this one, okay, if you transfer here 1 minus e to the x cos alpha, which is 0. Okay, let me show you here. E to the alpha cos alpha is equal to 1. That means if you transfer there, 0 is equal to 1 minus e to the alpha cos alpha. Okay, so 0 by something is 0. Okay, and similarly f of beta also 0. Okay, that means f of alpha and f of beta are equal. Okay, this is our Rolle'S theorem. So f of alpha and f of beta are equal, so there exists at least one root, let's say gamma, which belongs to open interval of alpha and beta. Okay, there exists some number, some value which is alpha, gamma, let's say gamma, such that our Rolle'S theorem is f prime of that gamma is equal to 0. That's good. Okay, now f prime of gamma, if you substitute here, okay, this one, in this one, if you substitute here in place of x gamma, you get what? Sine gamma minus e to the minus gamma, which if you simplify this equal to 0. Okay, because f prime of gamma is 0. Okay, Now if you simplify this, you get what? E to the gamma sine gamma is equal to 1. Okay. No, sorry, no. If you simplify this, e to the gamma sine gamma minus 1 is equal to 0. That means which is this gamma is between alpha and beta. Okay. Now hence alpha is a root of e to the, in place of gamma, if you replace x, sin x minus 1 equal to 0. This one is what our question say. This one here, this one we get here. So this is about our Rolle'S theorem. Okay, application of Rolle'S theorem.